All right. So here we have essentially doing it completely reverse. Before we had an acid we were talking about. Now we have a base. There's actually several ways you can do any of these problems, of course, because it's real world mathematics. It's not a game. And so, in the real world, there's many pathways to the same answer. But in this case, they're giving you actually all the work done. So we might as well just use that, right? And not have to do the work ourselves. And so this is the reaction for a weak base reacting with water to form the conjugate acid. That is actually the reaction they're talking about here. That's a buffer, okay? A buffer just has a significant amount of both forms, the base and the conjugate acid. In this case, NH3 would be your base, NH4 plus would be your conjugate acid. And so they've actually went ahead and solved this KB expression for you. And if you remember your KB expressions, you can typically just plug in your initial values for these concentrations here. See that? And that's actually what makes the Henderson-Hasselbalch work as well, is because typically the amount of acid or base you use up compared to what you start with just won't make any difference. It won't change the numbers. And so what we do here is we just use this equation they've given us. We want the pH of this, but we can get the pH from the OH minus. So let's just do that first. So we find the OH minus by taking the KB, 1.8 times 10 to the negative 5, and we multiply that by the base, and that's 0.38. And then we divide that by the acid, which is 0.90, which is this one right here. Okay? Okay. Is that making sense so far? All right. By the way, yes, this is actually what the Henderson-Hasselbalch was derived from. So we're actually kind of just doing before we would go into pH for Henderson-Hasselbalch. And yes, you could use the Henderson-Hasselbalch here, okay? Would you like me to show that after I do this one? How you could use the Henderson-Hasselbalch? Okay, so we do the math. So first we take 1.8 times 10 to the negative 5th. We multiply that by 0.38. We then divide that by 0.9. And that will get us our OH minus concentration, which in this case, for my values that I have in this problem here, is 7.6 times 10 to the negative 6. Okay, so to do the pH versus POH, the easiest way to do this is to go into POH first, okay? Because if you remember, you actually have an equation that's been given to you as 14 equals pH plus POH, right? And so if we get the POH, we can just subtract that number off of 14. So it'll be very easy. How do we get the POH of something? Well, again, that P stands for negative log, right? And so we're going to take the negative log of our 7.6 times 10 to the negative 6. We take that negative log. That value for our POH is 5.1192. I might give some extra sig figs just so I don't get rounding error. Okay? Is everything clear up to this point? Again, we want to go from the OH minus concentration to POH. P is negative log, right? And so we took the negative log of this concentration times 10 to the negative 6 right here. Okay? And that's that value right there, the 5.11. Okay. Okay, so whenever you want to go to the other thing, we have the POH. That's not what we want for this problem. We want the pH. So we just have to take 14 and subtract off our answer here. So 14 minus 5.1192. That will give us 8.8. So our pH equals 8.8808. We only need 3 sig figs though. So 8.88. Okay, does that make sense? Do you have any questions? Would you like to see how to use the Henderson-Hasbach to do this? Okay. Dock it, and we'll use the Henderson-Hasbach. Okay, so if you remember your Henderson-Hasselbalch, that was your pH equals pKa plus the log of the A minus. In this case, the A minus would be right here, the base. So 0.38 divided by 0.9. We'll just play around with the Henderson-Hasbach real quick and see what happens, huh? Okay, so you need the pKa though, right? But wait, we have a Kb, don't we? So even if we took the p of that, the negative log of that, we wouldn't get the pKa, would we? We'd get the pKb. So let's go ahead and take the negative log of that, negative log of Kb, which is our value up here. So we take the negative log of 1.8 times 10 to the negative 5. And that's going to give us our pKb, which is 4.7447. Just stop there. Huh? Okay. Let's look at your numbers after I mess with the deal. Do you have the same numbers as me or different? Different, right? Okay. And so you have that 4.77. Well, how do we get the pKa of this? We just take 14 minus that value. Now give us pKa. And so that'd be 9.2553. So our pH would then equal 9.2553 plus the log of these values. I'm going to go ahead and solve those values just so I don't have to write them out. So 0.38 divided by 0.9, which is 0.422 repeating. 0.42 repeating. We take the log of that value now, and then we add it to 9.2553. We get 8.88. Zero 8 again. Whoa, huh? Same answer. See how we can do it multiple different ways. Because it's a real world problem, it's real world, right? There isn't one way to get there. Okay? And really, this is actually just like the previous part to the Henderson-Hasselbalch. So this is the base version of that. You can actually derive the same equation from the base. Okay? So anyways, that's that. I'm going to stop the video. I'm going to look at your numbers, figure out where we got off the rails. It happens very often because I'm saying my numbers